Hi everyone! In this video we will evaluate functions. Find d of -3 given the function d of t equals t squared minus 5t minus 2. The notation d of t is simply stating that we have a function and the input variable is a t. We typically have a function saying f of x, but we can't continue doing that for all of our functions, so we change it up and give ourselves different variables to indicate the function and the variable that's the input variable. So it is still the same notation as f of x, we just have d of t, meaning it's a function and t is the input variable. The benefit of having the function notation is two-part. Notating that it's a function says that every x has exactly one y value by the definition of a function, or that it would pass the vertical line test. The other thing is that we have the number that we're going to be substituting, or a different variable, with our notation. So when we say d of -3, this is not multiplying, although some of you may see that with the parentheses. Often the parentheses indicate that we're multiplying. This is function notation, and we read it d of -3. And that just means that we are replacing every variable or input with the -3. Before we do that, I like to put parentheses around every variable in the original. This helps me indicate where all of the operations are, and it's very important to keep track of those signs. In this case, I have a -3, and it will make a big difference on this first one. So as we substitute the -3 into those parentheses where the t is, so we end up with -3 inside the parentheses squared, minus 5 with parentheses, -3 minus 2. On the first one, where we have the -3 squared, if we hadn't put the parentheses, so I'm going to write it over here on the right. If we had no parentheses, we would have had -3 squared like this. That squared is only going to the 3, which makes it a 9, and then we keep the negative. This is not what we have for our function notation, because it is the entire variable squared. And where we have the parentheses around the -3 squared here, that means we have -3 times -3. A negative times a negative is positive, so we get a positive 9. Our next one is -5, and without those parentheses, it might have looked like -3. With them, we know that the operation is multiplication. And because we have a negative sign here, or a subtraction sign, we end up with -5 times -3. Some may think that that is just a subtraction sign, so let's go ahead and change it to add the opposite for those who aren't comfortable seeing that that minus sign or the subtraction sign is a negative sign for the 5. We end up with -5 times -3. A negative times a negative is positive, so we get positive 15. And the -2 or -2, we don't have any operation, so we just keep it. Now working from left to right, 9 plus 15 is positive 24, and then subtract 2 gives us a positive 22. So we could say with our function notation, d of -3 equals 22. And so we've evaluated the function at d of -3, which gives us the number 22. The other benefit of having function notation here is that we have the input and the output right there at the bottom, which is a little different than the equation method, which just says y equals the number. So in this case, I could write the ordered pair with the input and the output as an answer as well. So I have two different ways, depending on what's being asked, of writing the answer. And it's really convenient because you don't have to go back and look at what you substituted in for the variable. So we've now evaluated this function at d of -3, and now we're all done.